Okay, going to do a quick video right here about how to describe the relationship between an independent variable and dependent variable, and then to write an equation for it. So in this first equation, let's pretend we're an art teacher, or we're looking at an art teacher, and we're looking at the clay that they buy in pounds compared to the clay that they use, or that they can use in pounds. Okay, so the clay that they buy compared to the clay that they're able to use. So when the art teacher buys 0 pounds of clay, they have 12 pounds they can use. That means, okay, we have 12 pounds in the classroom before we start buying anything. When they buy 1 pound, now they have 13 pounds they can use. Notice this changed by 1, this changed by 1. So one thing we learned inside the lesson is that independent variables, when they change, they make the dependent variable change. So in this example, when we buy more, we have more. Kind of like the cause and effect idea. The cause, the teacher bought a pound of clay. The effect, they now have another pound of clay that they can use in class. So the clay bought is called the independent variable. The clay that they can use is called the dependent variable. Now, what we also learned in class is that independent variables are always x and dependent variables are always y. So boom, right there. The clay bought has to be the x variable. The clay to use has to be the y variable. Now, when we're trying to find a description of the relationship, I always like to check to see if there's an adding relationship first. And the way that I do that is I look at the x value and I ask myself, okay, if I added a number to this x value, what would I have to add to get to that y value below it? So to go from 0 to 12, it obviously has to be plus 12. So 0 plus 12 equals 12. Now, if that's really the relationship between x and y, it should work for every single pair on the table. So I check. Does 1 plus 12 make 13? Yep. 2 plus 12 make 14? Yep. 3 plus 12 make 15? Yes. 4 plus 12 makes 16. Yes. So I found my relationship. The relationship is that the y numbers are made by taking the x numbers and adding 12 to them. So that's how I'd write my description. The y values are made by adding 12 to the x values. So that's how you write a description. You just write exactly what you found the pattern was, going from the top numbers, the x's, the independent variables, to get to the bottom numbers, the dependent variables, the y values. And then to write the equation, we just kind of follow what our description says. The y values are made. So y is equal to, because that means, hey, I'm looking at the relationship. How is y made? Y is made by adding 12 to the x values. So the x values plus 12. And again, you could have said that the y equals 12 plus x, because that's true also, because the commutative property, x plus 12, 12 plus x are the same thing. So that's how we would find an adding relationship. But sometimes our relationships are not adding. So let's look at this one. So in this one, we're looking at time that you're driving in hours compared to the miles that you travel in miles. So if I'm driving for 0 hours, I go 0 miles. But if I change the time driving to 1 hour, now I've driven 40 miles. If I drive for 2 hours, 80 miles, 3 hours, 120 miles. So again, when I change the amount of time that I'm driving, it's making the miles, the distance that I've driven, increase. So that means that my time driving is the cause, which is also the independent variable, the cause I drove for an increasing amount of time. The effect, the amount of miles that I drove, increased. So again, this is my independent, which means that it has to be my x, and this is my dependent, which has to be my y. So again, I look for my adding, okay? To go from 0 to 0, well, that would be 0 plus 0 equals 0. So if this is an adding relationship, then all of the patterns should be plus 0 to get down to the other number. And I can already see 1 plus 0 is not going to make 40. So it's not an adding relationship. So if it's not an adding relationship, I'm going to check to see if it's a multiplication relationship. And I can also just check for these other numbers for adding as well. So 1 to get the 40 would be plus 39. But if you do 2 plus 39, that does not make 80. It makes 41. So again, the adding just doesn't work. But multiplication. So 0, 0 is not really going to help me out here because that's 0 times 0. But if I look at 1 to 40, to go from 1 to 40, what do I multiply 1 by to turn into 40? Well, I multiply it by 40, right? So now I check to see, can I do 2 times 40 to make 80? And the answer is yes, 2 times 40 is 80. Is 3 times 40 equal to 120? Yes. Is 4 times 40 equal to 160? Yes. Is 5 times 40 equal to 200? Yes. So that's my relationship. It's a multiplication relationship. So my description, I'm just going to say that the y values are made by multiplying the x values by 40. Because that's what we multiplied them all by. 1 times 40, 2 times 40, 3 times 40, 4 times 40, 5 times 40. So again, to make my equation, take my description and just put it down in symbols. The y values are made. The y values are made, y equals, by multiplying the x values by 40. And when we do 40 times x, we always write 40x because that's how we do it in algebra. Okay, so hopefully that helped out.